Hello, everyone. Welcome to First Online University, a global platform for all your education and growth related needs. In this lecture, we are going to start with a new topic, a new chapter that is haloalkanes and haloarenes. Now, the moment halo comes into picture, it means we are talking about halogens. Halogens include fluorine, chlorine, bromine, and iodine. So the arenes and alkanes of that contain a halo group are referred to as haloarenes and haloalkanes respectively. And in this lecture, we will be looking at an introduction to this chapter. So it's a very brief introduction that we are going to discuss in this lecture, and we will get to know about what these terms actually mean. Before we begin, a piece of information for you. You can use the coupon codes Mission JEE or Mission NEET while you enroll at First Online University for Mission JEE or NEET. Let us start with the introduction of haloalkanes and haloarenes. Now, when I talk about this simple compound RH, what do we call it? We call it as an alkane, right? But when this hydrogen is replaced by a halo group, that is a halogen, we get RX, that is the product, and it is called as haloalkane. Now, R is simply the alkyl part and X is the halogen group. So the name of the compound is haloalkane, or we also call it as alkyl halide. So alkyl halide is the common name of it, and otherwise it is called as haloalkane, which is the IUPAC name of it. So alkyl halide is the common name and haloalkane is the IUPAC name. For example, if we have say CH3CH2Cl, when we call it as ethyl chloride, that is the common name, but when we call it as chloroethane, it is the IUPAC name. I hope the difference is clear to you. Now, when I say ARH, now here AR is basically an aryl group. So this is basically an arene. Okay. Now, when again the hydrogen is going to be replaced by a halogen, that is X, what we get as the product is ARX, which is known as, AR here stands for aryl. Okay, so what we call this compound, we call it as either aryl halide, which is the common name of it, and the other name is haloarene, which is the IUPAC name of it. So when we have the alkyl group which is attached to the halogen atom or the group, we call it as alkyl halide or haloalkane. And when we have the halogen attached to an aryl group, that is an AR group such as a benzene, then we call it as haloarene or commonly known as aryl halide. Now, if we look at haloalkanes and haloarenes, the difference in what we have understood till now, haloalkanes basically contain the halogen atom or atoms which are attached to the R group, which is the sp3 hybridized carbon atom of the alkyl group. Whereas in case of haloarenes, as we talk in case of benzene, all the carbon are sp2 hybridized, and therefore haloarenes will contain the halogen atom or atoms being attached to the sp2 hybridized carbon atom of an aryl group. For example, if we have CH3CH2X that I gave you the example, it is the example of haloalkane, and when we have a halogen directly attached to the benzene ring, it's an example of a haloarene. So haloethane and haloarene are the examples of it. Now, what we have seen till now, based on that, let us do a few concept checks to see how much we have understood in terms of the introduction to this particular chapter. The first question is, what is the name of this particular compound, CH3CH2X? Now, if we look at CH3CH2, it is simply ethyl group and X is the halogen. So we can call it as either ethyl halide or we can call it as haloethane. So if we look at the options, option number C is going to be the right answer here, ethyl halide that I've already told you. So depending upon whatever the options are given to you, you have to choose the right answer, whether it is a common name or IUPAC name. You have to choose whatever has been given in the options. The next question is, in haloalkanes, halogen atom. So here we have already seen that in case of haloalkanes and haloarenes, in case of haloalkanes, since we have the alkyl part where the carbon is sp3 hybridized, so halogen atom is going to be attached to sp3 hybridized carbon. But when we talk about haloarene, where we have all the sp2 hybridized carbon, then there the halogen atom is going to be attached to sp2 hybridized carbon. So here when we are talking about haloalkanes, what do we see is that halogen atom is going to be attached to sp2 hybridized carbon atom of aryl group, sp3 hybridized carbon atom of alkyl group, sp3 hybridized carbon atom of an aryl group, which is actually not possible, or none of these. So we have seen that the carbon atom is sp3 hybridized, and as it says alkanes, so it is going to be of the alkyl group. So option B is the right answer here. Next question is, in haloarenes, halogen atom is attached to. So we have already seen that in case of haloarenes, the halogen atom is going to be attached to sp2 hybridized carbon of the aryl group. So wherever you see this particular option, you will tick that option because that is going to be the right answer. Here we see that sp2 hybridized is anyhow present in just one option. And as it's clear from the name, we are talking about arenes. So it is going to be the aryl group. So option A is the right answer here. This is all about the introduction to this chapter. We are going to move on to advanced topics in this particular chapter from the next lecture onwards. So in this lecture, we have discussed the very, very basic part of it, which should be like not difficult for you to understand. It is very simple. Just to identify what haloalkane looks like and what haloarene looks like and what do we mean by haloalkane and haloarene. This is a very simple basic introduction that we have discussed. So there is nothing to memorize in this. It is just that you have to understand so that you can understand the upcoming lectures. You can subscribe to our YouTube channel for joining YouTube live classes for best NEET or JEE coaching. You can also download the First Online University mobile app through Google Play Store or App Store for continuous learning through your smartphones. Keep learning with First Online University, a team of millions of learners and educators worldwide.